Now let's turn to the challenge of climate change and energy sources. Our science correspondent Miles O'Brien is asking, can alternative energy sources really help?
Let's take a ride, shall we? All right, so what is this?
It's a Toyota Mirai fuel cell vehicle.
Mirai means future in Japanese.
Jack Brower is director of the National Fuel Cell Research Center at the University of California, Irvine. He is convinced a future that runs on hydrogen, like this car, is finally around the corner.
How's the performance?
It's nice. You could actually design a fuel cell engine that could be just as fast as any battery engine.
A fuel cell generates electricity by relying on the natural attraction between hydrogen and oxygen molecules. Inside the cell, a membrane allows positive hydrogen particles to pass through to oxygen supplied from ambient air. The negative particles are split off and sent on a detour, creating a flow of electrons, electricity to power the motor. After their work is done, all those particles reunite to make water, which is the only tailpipe emission on these vehicles.
The main thing that is a benefit from the fuel cell engine is you can go farther, and then of course hydrogen's light, so you can put a lot of hydrogen on board a vehicle and have it carry its full payload.
Up until now, fuel cells have had a bumpy, sporadic ride. First imagined in 1839, they finally moved into a real-world application in the 1960s, when NASA developed them as a way to generate electricity on Apollo spacecraft. Then, 40 years later, President George W. Bush pledged more than $1 billion in federal funding to spur widespread adoption of hydrogen fuel cell cars.
With a new national commitment, our scientists and engineers will overcome obstacles to taking these cars from laboratory to showroom, so that the first car driven by a child born today could be powered by hydrogen and pollution-free.
But when people looked under the hood, they were less impressed with the idea. After all, most hydrogen is produced with methane, so there really was nothing climate-friendly about hydrogen.
You could probably say it was a little bit of greenwashing.
Yeah, I would agree with that. And it kind of tainted hydrogen a bit, if you will, as something that enables fossil to keep going.
But they never stopped going here, and now are drawing renewed attention and funding. The reason? Cheap and increasingly plentiful wind and solar power generation make it possible to employ renewable electricity to split water molecules, making hydrogen carbon-free, so-called green hydrogen.
Is there currently a hydrogen renaissance in your view?
Absolutely there is. Almost all jurisdictions that have objectively considered how do we achieve zero emissions in all end uses, they've come to realize that the features of hydrogen are required for making all of those sectors zero emissions.
Required because batteries alone will not get us there. Planes, trains, ships, and trucks need less weight and longer range than batteries will likely ever provide. At the Port of Los Angeles, Toyota is road testing some fuel cell powered trucks.
All right, here we go.
Veteran driver Danny Gamboa gave me a spin. He's been evaluating hydrogen fuel cell trucks for the past 5 years.
So this truck is different because it, as you can tell, it's a lot quieter.
Sure is.
It has a lot more torque and power, and it doesn't pollute. So the only thing coming out of the tailpipe is water.
For Gamboa, this project is personal. On an average day, 16,000 trucks haul freight in and out of the Port of Los Angeles. He and his family live nearby, and all of his kids have asthma.
I think that the frontline communities shoulder the burden of the truck emissions, and they get very little help. If I can do whatever I can do to push that needle, I'm going to do it.
Toyota made its first big bet on hydrogen vehicles 30 years ago.
So in this room, this is a fuel cell garage, and what we do here is really take a look at the vehicle at a very kind of deep level.
Craig Scott is general manager of Toyota's Fuel Cell Solutions Group based in Gardena, California.
The good news really for both hydrogen and batteries is the technology exists. This is not a fundamentals of physics problem. This is an engineering exercise and development of resources and bringing scale to this. Right? When you're moving away from the incumbent that's been around for 100 years, there are going to be costs associated with that.
California provides incentives to address the chicken and egg issues. Jack Brower took me to one of the 45 hydrogen filling stations in the state. Hydrogen is energy dense, but also the lightest element on the periodic table, so it must be highly compressed or liquefied to be distributed.
It will always be more expensive than gasoline to move around in society. This is why the infrastructure is the key, because if we can have these built, many of these built, and we can actually make a whole bunch of liquid hydrogen and deliver it this way, it'll become less expensive.
Getting to that point is driving a lot of work here at the National Renewable Energy Laboratory in Golden, Colorado. The bipartisan infrastructure bill includes $9.5 billion in federal funding for hydrogen technology development. The Department of Energy is spearheading an effort to seed the market with hydrogen distribution hubs across the country.
I think to go big, to really get toward a national hydrogen network, the government incentives and government support and partnership are critical.
So this is the Energy Systems Integration Facility.
Mechanical engineer Keith Whipke runs the Fuel Cell and Hydrogen Technologies Laboratory here.
What are you working on in your lab right now that's going to make this all happen?
Definitely the number one goal is to make hydrogen cost less to produce it. There's an ambitious hydrogen shot goal to get down to $1 per kilogram in 1 decade. Solar and wind took 30, 40 years to get to where they are now. We need to do the same thing with hydrogen in just 10 years.
They are refining every aspect of hydrogen production. Here they are testing new materials and techniques to improve the performance of devices called electrolyzers that can pull hydrogen out of water.
The magic is in how do you do that with as least electricity as possible. And that's really where our research is.
To complete the picture, they are building an extensive wind and solar farm to power hydrogen electrolysis. The hydrogen can be used for grid-level energy storage, providing power when the wind is not blowing and the sun is not shining.
So hydrogen can enable an all-renewable grid, potentially.
Absolutely. Hydrogen can enable a huge penetration of renewables onto the grid and not need those baseload power plants that are typically using combustion today.
Hydrogen is once again seeing a moment in the sun, and this time the technology and the urgency may spark a more positive reaction. For the PBS NewsHour, I'm Miles O'Brien at the Port of Los Angeles.